Ever been in a situation where you had to leave your desk in a hurry and you forgot to lock your devices? That gives others a chance to peek into your system. Or worse, do something malicious. No more. Meet our little guardian, this BLE beacon dongle. With the power of Python on your PC and a bit of Android magic, your device now locks the moment you leave its proximity. Now, even if someone tries, they just can't get in. And the moment you are back, your screen is ready for you. Just enter your password and boom, you are in. But that's not all. This proximity setup can be extended to almost anything. For example, to automate smart appliances, and so much more. In this video, we will walk you through how to set up this BLE proximity lock using an nRF52 dongle, a simple coin cell battery, and your PC. We will take a look at the code, examine the hardware setup, and learn how to power the dongle using an external supply for long-term use. Then, we will break down the Python script that runs on the PC and see how it interacts with the beacon in real time. And finally, we will wrap it all with a live demo to showcase the entire system in action. In the upcoming video, we will show you how to do the same setup for your phone using an Android app. Namaste and welcome back to Avinashi Tech, where ideas meet innovation. Here, we explore the world of embedded systems through hands-on projects, in-depth tutorials, and real-life applications that go beyond the basics. If that sounds like your thing, make sure to subscribe and hit the bell icon so you never miss out. Let's quickly recap what we covered in the last video. We discussed what BLE beacons are, explored popular formats like Eddystone and iBeacon, and even implemented all three, including a custom format, into our nRF52 dongle. If you haven't seen part 1 yet, click the link on the top right corner to watch it first. It will help you understand how our beacon works. Coming up in the code part, we will move forward with our application using the custom advertising format, which includes just a flag field and a 128-bit UUID. So, on the nRF52 side, there's no change from the previous code. What we are adding now is a Python script on the PC side to monitor and react to our beacon's presence. Let me open the script. We are using the BLE library to manage BLE operations. If you have been following our ESP32 BLE OTA videos, you might recognize it. Here's how it works. We specify the 128-bit UUID of our beacon, define a function to continuously scan for nearby BLE devices. In the main loop, if our nRF52 based beacon is detected, we read its RSSI. If RSSI is above a certain threshold, that means the beacon is closed. And if the screen is locked, we try to wake it up using PyAutoGUI module. If RSSI drops below a certain threshold or the beacon is not detected at all, we lock the screen using the OS module. Simple, effective, and completely connectionless. Now, let's talk about the hardware setup. By default, the nRF52840 dongle is powered via USB. But if we want to run it off a coin cell battery for portability, we need a small but important hardware tweak. Here's the change. Flip the dongle and you will find two shoulder bridges, SB1 and SB2. By default, SB2 shoulder bridge is closed, which means it's connected, and therefore it allows for USB to power our chip. SB1 is open, which basically disconnects the external power. To use an external supply like a CR2032 point cell in our case, we need to cut SB2 and solder SB1 shoulder bridge. This routes power from the VDD out pin instead of the USB pin. But a very important caution, that is to never close both SB1 and SB2. Why so? If both USB and an external power source are connected simultaneously, that could lead to potential damage of your USB port, the coin cell, or even the dongle itself. Also, one more important thing, that is, the shoulder points are very tiny. So, take your time and use a fine tip soldering iron. Once the modification is done, I have connected a CR2032 battery to the VDD out and GND or ground pin of our dongle. That's all that we need to know. Now the beacon can be powered without a USB. If you need to reprogram the dongle, let's say using the nRF Connect Desktop app, you just need to undo the hardware change temporarily by reversing the shoulder bridges as we have discussed earlier. It's time to finally run the project. So you got to turn on Bluetooth on your PC. After that, just open PowerShell. Navigate to the directory where your Python script is present. Enter the command and run the script. As the script runs, it continuously scans for the device and prints the RSSI values. Right now, since the dongle is in my front pocket, RSSI is strong and the screen stays on. As I walk away from the desk and wander around so as to let my RSSI signal drop, that causes it to fall below the set threshold and the script triggers a screen lock. When I return back and the beacon comes back in range, the signal strength improves and the script wakes the screen using automation. Now, some of you may be wondering, can we make it automatically enter the password too? Well, technically yes. If you combine BLE scanning with BLE HID keyboard mode, it's absolutely possible. In fact, we've got a dedicated video right here on this channel that shows you how to turn your nRF52 dongle into a BLE keyboard. Do check it out if you are curious. But coming back to our current topic, while entering the password over BLE HID mode is possible, it does come with trade-offs. It's less secure if you don't enable BLE security features. That is, the password could travel over the air in plain text. Second, it's more power hungry since HID mode requires an active connection. And third, it's tricky to implement reliably. You must know exactly when to send the password. If you are too early or too late, things can go wrong. What we have done here is more subtle and secure. That is, no Bluetooth pairing or connection required. So, lower power usage. No password is stored or transmitted, so it's safer. Purely proximity-based automation using passive BLE scanning. Simple, efficient, and secure. Just how it should be. And that wraps up part 2 of our BLE Beacon Proximity Lock Wake Up project. We reused our beacon code from part 1, added a simple yet powerful Python script, made minor but essential hardware changes to our dongle board, and successfully automated screen locking and waking up using just signal strength. Let us know in the comments how you plan to use this in your setup. Don't forget to like, share, and subscribe to Avinashi Tech for more such hands-on tech projects. See you in part 3, where we will take this idea to the next level using our smartphone.